Welcome back. In this lab, we are going to perform the practice program, which is in Chapter 2 in the current version of the Savage Text, the 10th edition. This is number 2 on page 104. In previous versions of the textbook, if you have an older version, the 9th or 8th edition, it may be number 12, but it should be around the same place, page 104 or 105, and it's practice programs in the end of chapter 2. So in this program, we are going to write a program that inputs a double for n and iterates through the Babylonian algorithm 100 times, or it says for a more challenging version, iterate until your guess is within 1% of the previous guess. So this is what we're going to do. Okay. So I'm going to create a new project, and we can go ahead and continue to use the console app, and I'm going to call this Babylonian Algorithm for square root. And it wouldn't be a bad idea when you name your projects to let yourself know what chapter they're coming from. All of the tests in this class are open code, so you can look back on any of your previous projects. And that's a real world scenario. You know, if I'm writing a program or adding a feature in a piece of software during its life cycle, and I have whatever it is that I'm trying to do, I have done it before in maybe some other program, then I look back at those and just kind of refresh my memory. What's the best practice? You know, how could I maybe even write it better than I did before? So I'm constantly looking at my old code. So you want to be very organized. Keep all of your old projects. Keep everything from this class going forward. You'll never know when you might need it again. So I'm going to call this Chapter 2. Chapter 2, we can just leave it at that, Chapter 2. Or if you want to put the number in the book, you could. So this was Chapter 2, number 2. All right. Okay, so this C++ program will have that hello world code block in there, and I'm just going to delete what we don't need. And I'm going to add that using directive. That way we don't have to continue to put that standard qualifier in front of each cout statement. Okay, so if you can, when you start writing a program, determine what variables you need from the start. You can always add variables as you write, but I typically look at my program and say, all right, what am I going to need? And in this application, you can see that we're going to need the value for n, the value for r. We'll also need our current guess as well as previous guess. And for previous guess, I'm using camel case. In chapter 1, I believe, the Savage Text talks about naming conventions. And actually in the last program, the constant for the acceleration due to gravity, I should have capitalized it and made it screaming snake case. You can take a look at those naming conventions. Actually, those are on page 45 on chapter 2. They mention camel case. They probably mention screaming snake case when they cover constants. But this is camel case. So it's a camel, it's got a hump in the middle. So your variable name, you just smash all the words together and you just capitalize every letter in each additional word, not capitalizing the first. Now, if I were to capitalize this first letter like this, that's known as Pascal case. And that is what's typically used in C# or Java for class names. C++ convention, everything is lowercase. Actually, you could use Pascal case in class names in C++ as well. Wouldn't be a bad idea. As far as naming conventions are concerned, however, once you find yourself in a development role, you should follow whatever naming convention is being used with the team. If you're programming with the team, you should all follow the same convention and decide that together. These are pretty standard, though. Usually, Pascal case for class names, camel case for regular variable names, or in Java, method names are camel case. Same with C++. C# makes a distinction there. C#, you name all of your properties and methods. You use Pascal case with a capital letter at the beginning, and that just helps you identify what you're dealing with. So now we have our variables in place, and I'll go ahead and add that comment here. All right, and next we want to prompt the user for the number that they're trying to find the square root of. So prompt user for a number to find the square root. So enter a number to find the square root. And I'm going to get rid of that end line there. Anytime there's user input in a console situation, I usually I like for the cursor to be blinking next to the colon that I create. That's just a style choice on my behalf. So we're going to read that in using our extraction operator, extracting from the console. And we're going to store that in n. That's our number that we're trying to find the square root of. Okay. So then they tell us that the Babylonian algorithm is performed by taking the number that you're trying to find the square root of, then dividing that number by some guess. And that initial guess, they're telling you to use half of the number. So n divided by 2 is your initial guess. So you make your initial guess, then you take that guess and you divide n by that guess, and that gives you an r, which would be the square root. Then you set your next guess equal to the previous guess plus the r that you just previously computed, and then divide by 2. And then you repeat that. You repeat steps 2 and steps 3 until we are within 1%. The two guesses are within 1% of one another. So on instruction 1, they tell us to make a guess and start with n divided by 2. So that is what we are going to start with here. Assign initial guess equal to n divided by 2. Okay. Then instruction 2, they tell us to find the square root by dividing n by the guess. Okay. Then we're going to set our next guess equal to the guess, our current guess, plus r, and divide that whole thing by 2. Okay? And then they tell us to repeat, go back to step 2 for as many iterations as necessary. The more that steps 2 and 3 are repeated, the closer the guess will become to the actual square root. Okay, so this is where our repetition structure comes in. So there is a theorem called the Baum-Jacopini theorem that was developed in the 1960s by a couple of mathematicians. And that theorem states that any software program can be written as long as that language contains the 3 primary control structures. So this is a very, very key thing. For those of you who have never developed before, every single programming language does have 3 control structures. Those are sequence, meaning that every line of code that you write executes in the order that you wrote it. And the only 2 programs we've written so far, that's the only control structure that we've used. So that's the basic control structure. Second one is the decision structure. The decision structure is a block of code that may or may not get executed depending on some Boolean condition, Boolean meaning true, false. And there's several different types of decision structures. There is the single branch, the dual branch, so one of the 2 blocks will execute depending on the Boolean statement. And there's a multi-branch, if, else, and then the switch statement, which just simplifies the if, else, multi-branch. That is the second control structure. The third control structure is the repetition structure. This is a block of code that executes repeatedly until some condition tells it to stop. And there's 3 main types of repetition structures. There's the while loop, the do while loop, and the for loop. You'll also see in modern programming languages, just about all of the modern languages have for each loops as well, which is similar to a for loop. It can internally determine how it basically interfaces the IE numerable. That's at least in C#. What that means is it can internally count how many items are in a collection and just cycle through all of them. We'll talk about that, cycling through arrays, in upcoming projects. So all of these repetition structures are interchangeable, meaning you can write any one of them. And I've worked in some languages that only have a while loop. For example, when I worked in the banking industry, I think it was called the Scimitar programming language. Anyway, it was a software piece that Jack Henry wrote that they sell to credit unions, and so it's a proprietary language, and it only had a for loop. Anyhow, so we can choose really whatever loop we want, but some loops make your development a little bit easier or lend themselves to a little bit cleaner looking and flowing code. And in our case, what I'm going to choose to use is the do while loop. The do while loop is what's known as a post-test loop, meaning that the loop will absolutely execute at least once, then it tests, post-test loop, then it tests your Boolean condition. If the condition is true, then it loops back. So your body of code that's in the loop will absolutely get executed at least once, and in our case, we do want that. The while loop and the for loop, depending on your initial conditions, the loop may not execute at all. Okay? So what is our Boolean condition in this case? Well, the program says loop until, or keep doing this, keep performing instructions 2 and 3 until you are within 1%. So your previous guess is within 1% of the current guess. So that's going to be our statement here. How do we write that? Well, my previous guess, if I subtract the two, previous guess minus guess, that needs to be, in order for the loop to continue, remember that this test is whether or not the loop should keep going. So in our case, we want, if the previous guess minus the current guess, if that is greater than 1% of the previous guess, then that is when we want to continue. So if this is greater than 1%, keep going. Once that is false, once the previous guess minus the guess is less than or equal to 1% of the previous guess, that's when we want our loop to stop. A common mistake that developers make when writing a do-while loop is they forget the semicolon. While loops and for loops don't have semicolons at the end of their Boolean statement in parentheses, but do-while loops do have a semicolon there, so don't miss that. Okay. Now here's the problem. So far, previous guess, we haven't even assigned it a value yet, right? So when and where do we do that? Well, this line right here, line 22 in my code, is a destructive action. All assignment statements are destructive, meaning whatever was previously inside of this guess variable, it's going to be replaced with this. So this is where our guess is some value here. That value is used in evaluating this arithmetic statement, but then once that is evaluated, the new value is stored in guess and the previous value is destroyed. We want to preserve that, so I'm going to do that right here. Now, I'm going to pause for a minute. Notice this window that's popping up as I type. This is called IntelliSense inside of Visual Studio Community. Most major IDEs have some mechanism like this, and what it's doing is it's trying to predict what you're about to type. That way you don't have to type the whole thing. Here I can just use my arrow keys and select previous guess, and the tab key will select it for you. Okay, so and then what I usually do as a developer, I'll type only the letters I need until it's picking the right one. In this case, after GU, it picked guess for me. I can hit tab. If you can learn to do that and just kind of watch that as I'm typing, if it's a variable name or if it's a property or a method name, then I just type only enough letters until I see it pop up in IntelliSense. I hit the tab key and it goes in. So if you can learn to do that, it will speed up your development. Okay. So now our repetition structure here should keep iterating until our guesses are within, our last two guesses, or previous guess and current guess are within 1% of one another. Then once they are, well, it'll loop until they are, and then once it stops looping, then we know we've got our current value. So all we need to do now is to display the result. Okay, so cout statement, and I'll say an approximation of the square root of, and then I'll display in. And I'm going to go over to the next line here. just so everything fits on the same screen. Let me put a space there, is, and then we just want to display our current guess. The current guess is within 1% of the previous. This one should be the most accurate versus the previous, right? Because it's the most recent. And so that's our answer. Okay. So let's try it. Let's run our program here. Okay, enter a number to find the square root. Let's enter a number that we know the square root of. I'm going to do 121. Square root should be 11. Hit enter. Look what it gives us. An approximation of the square root of 121 is 11.0002. Okay, so, and in fact, this is how most calculators calculate things like square root. They approximate it, and then they may even round at a certain point, so they may have something like that built in. But there we go. We've wrote a program that can calculate the square root. How great is that? So one other thing I want to bring up now. Now is a good time. Now that we have loops. Loops is when you introduce loops or when your program needs loops, it's complicated enough to where you need to be able to debug, because you may not write your loop correct the first time. Now, I wrote this exactly as it should be right out of the gate, but you may not, and I think the first time I wrote this, I probably had to switch some things around a little bit to get it working properly. So what if you write your program and it doesn't seem right? You're getting a value that doesn't look like it's correct. How do I debug that? In Visual Studio, you can put a stop point in by clicking in this gray area that's to the left of the numbered lines. Okay, and then now if I run my program, okay, it will still launch. And let's try that 121 again. I'm going to type in 120. Actually, let's try something different. Let's do 144. That should be 12, right? So I hit enter, and notice it stopped right here on this line. So my guess is 72. That's 144 divided by 2, right? And then R is 2. That's going to be, obviously the previous guess, n divided by the previous, or by your initial guess, which just gives you 2 to begin with. So you could actually shorten this a little bit, but we were just following the instructions as they were written out. So here they show us what previous guess is. Actually, notice there, previous guess hasn't been assigned yet. Notice the value there. It's by default a double. It may have some random value before you assign it something. So when we're debugging our program, up in the toolbar, the top right, you'll see some buttons here that control the flow of your debugger. There's step into, step over, and step out. Step into, if this is a method call, it will go into that method. If it is, if you're inside of a method, step out should step out of it. I want to do step into. That will go through every single line of code, no matter where it's located. So notice what it did there. It went to line 23. Now you can see my previous guess was assigned the value of 72. And here I can see what all of my values are. Step in again. Now it goes to the while loop. Guess is now 37, which was 72 plus R, which was 2 divided by 2. And here you can see your values there as well. So this is the debugging tools within Visual Studio community. You will absolutely need these as a developer. You'll need to be able to step through, especially as a beginning developer. If you're first time writing something, it probably isn't going to be right, and you'll have to step through it and see what are the values. What am I missing, or what is it doing what is it doing that it shouldn't be doing, or what is it not doing that it should, and that should help you a great deal. Will help you a great deal. You also can see the values down here. You can also see the call stack. These are methods that are getting called. If you've heard of Stack Overflow, that's when too many methods have been called. Methods are the way the compiler works is it puts all these method calls on the stack, and then they are a first in, first out, or a first in, last out structure, actually. So they just get piled on top of one another, and then they as they resolve, then it, so methods can call methods anyway. That's for those of you who've never programmed before. We'll get to that. We'll get to method calls. Right now, we only have a single method or a single function. The term function and method are quasi interchangeable. That in C# or C++, these are all just called functions. I tend to accidentally call them methods. I think technically a method is when it's inside of a class. But anyway, I don't want to get too far into things for my beginners. Correct terminology is important, though. Okay, so I'm going to go ahead and hit, once you're done debugging, if you want to continue, just hit go. And actually, this continue will go to the next stop point, and if you're inside of a loop, then it will loop back to the next place. Okay. And our program finished. There we got the answer. 120005 is an approximation for the square root. Okay. All right. This is definitely a challenging program. Hopefully you were able to follow and understood how we put it together. Don't be discouraged if you don't think, as a beginner, if you don't think you could have created this, on your own, out of the fly. That's why we were doing it together. But you're going to get plenty of practice working on these. So again, for you beginning developers, your homework this week, it may take you a couple hours to dig through, and it can be very frustrating. Let me say this. If you are working on a program and you are stuck and you can't get further, I wouldn't spend any more than 45 minutes being stuck. Walk away from it. If you want to come back and try it again on your own with a fresh mind, I don't know how many times I've done that, walked away, and then the next day even, then the solution hits me, or I'll realize what I was doing wrong. Not sure if I mentioned this in my first videos or not, but paired programming is becoming a very common thing in software development. The company I work for, their digital engineering department does paired programming. This is called extreme programming, or XP programming. So two people are on one machine working on the same piece of code. And the benefits of that is one person might catch something that the person watching might catch something that the person typing missed, a semicolon. Usually it's something small, or the name of a variable, incorrectly naming a variable. So there's a lot to be said about getting someone else's eyes on your code. So walk away if you're having trouble, and send me your code. Email me, and I'll take a look at it, and I'll help you out. Okay? So if you get frustrated, walk away, email me. I'm happy to help you. All right, happy coding. Hope you do well on your first homework assignment. Definitely get started on it early this week, and email me if you have problems. Make sure you know yourself.